Okay, very good. Thanks everyone for allowing me to join. I'm at our Salt Lake City headquarters to show you our demo room and let you hear especially our BMA 360 beamforming microphones. I'll show you what these microphones look like. I have one here that I can show you. You can see just a 2x2 tile. They're very thin, very lightweight, very nicely made. You can see the amplifier here to drive those 4 15-watt loudspeakers. So I'll demonstrate a few things for you. I'll demonstrate the good fidelity from the microphones in this very large room, which I'll show you. And I'll discuss some of the audio technologies, as well as demonstrate for you a few things that we can do with our system. All right, so let me change my camera view so that you can see the room. Very good. So it should come into view here. We're using 3 of these BMA 360s here in this room. We have one near the presenter's station where I was standing to begin. We have another one here, and you may be able to see them with the LEDs. We have green LEDs for the BMA 360s. Okay. And I'll go and step to the back of the room. So this room is quite large. It is 13 meters long and 9 meters wide, 45 feet by 25 feet. Okay, so as I'm walking through this room, I should be coming through to you with very nice, intelligible audio. My voice should be very clear to you, no matter where I am in the room, from wall to wall. This is because of our PhiBeam technology, which is going to make my voice sound very natural, and our DS Beam technology, which is rejecting the reverb and the noise and the ambience in the room. So as I pass through the room, my audio should be coming through to you very evenly, no matter where I am, if I'm seated or standing, if I'm close to a microphone or far away. Even if I have my back. Okay, so I did want to show you just a couple of things. If I can share my screen, should be able to see my screen here with this video that I'll be playing. In this video, you'll see me. I'm here on this side, and Ryan, he's on our call as well. He's one of our engineers. So in the video, we'll be talking back and forth. In between us in the ceiling is one of our BMA 360 microphones. And then this wheel of color here, this is actually a live look at the software, which will actually show the beamformer following the conversation. So that when Ryan is talking, you will see beam 8, the green beam. When I'm talking, you'll see beam 3, this beam. So as Ryan's talking, you'll see 8, and then me. This is just showing the way that our beamformer is working to deliver that very natural sound that is rejecting the parts of the room that are not being spoken from by the active talker. Even when we're off screen, you can see who is talking. If we could see, we would see just where that audio is coming from. So we can do very interesting things with this geographical information. I'll show you a couple of them. We can do silencing, okay? And that means that I can program a beam to be silenced, to be active, but yet to attenuate the audio by a programmed amount. I can also assign camera presets to the active beam, so that if someone is standing in this position in beam 9, we can have a camera preset look in the correct direction and look at the person talking. And that technology actually is happening natively inside of our Converge Pro 2 DSP. And I'll demonstrate this for you, but again, there will be no control system required to control a camera. All right, I'll stop sharing and I'll demonstrate a couple of these things that I was discussing. So now that you can see my room again, sorry, yeah, okay, so you can see me. What I'll demonstrate here for you is our beam silencing. So we're using this technology, beam silencing, to silence the audience so that the presenter can be heard, can be audible, like me now, but as I step into the part of the room where my audience would be, my audio will be silenced. So I'll just go ahead and keep talking, and you'll see me step into the main part of the room. All right, 1, 2, 1, 2. I'll come just back over here, back into the presenters area, and be audible once again. And we can control features like this with a touch panel if you would have a control system, or with GPIO switches, which is what I'm doing here in this room. So that was our beam silencing. All right, the next thing I'll demonstrate for you is our native camera tracking. All right, so I am ready. Here we are. I'm using our Unite 260. This is our 4K optical PTZ camera with 3 multiple simultaneous outputs. So you'll see that the camera has come and looked in my direction, and that's because I'm talking. It is our BMA 360 here, that active beam, just like I showed you in the video. That beam is assigned to this particular camera preset that you're seeing. I'll step over here, and I'll move into the next beam over, and we'll see the camera come and move in this new direction. A different beam is triggering a different camera preset. And I'll go ahead and do this one last time. And once again, we'll see the camera come and look in my direction. So again, this is happening natively inside of our Converge Pro 2 DSP. You can connect an optical camera like this, either with an IP connection on a switch or with RS-232 using a VISCA connection wired directly between the camera and the DSP itself. And in our particular instance, we're using IP to control the camera. And I can show you in the software just how easy this is to put together. It's very stable, which is something that I like a lot. Yeah, very good. All right, so I'll begin here just by showing the matrix which has bound our microphones, and in this case, our beamformer microphone, to camera presets. So this is just a screenshot, but what you should be seeing here is a matrix which is connecting active microphones, or in our case, active beams, to camera presets. Now this is a truth table. It will be scanning from left to right continuously, looking for a true statement. So if beam 1 were active, if that is true, then this particular preset would be called. If beam 2 were active, then this particular preset would be called, and so forth. So our DSP natively can support one PTZ camera that has either that IP or RS-232 VISCA connection for native camera control. And as you can see, we could have up to 13 camera presets. I just wanted to, in the software here to begin, just show you how we would configure these ceiling tile microphones to fit a particular space. So in this case, what we're looking at is here is our tile, and we can see that it is designed to cover 14 feet by 10 feet, or 4.25 meters by 3 meters. Now this is a preset. You could go and change from a rectangle to a square room like this, or for a classroom, you could even go and use this. Let me turn this. Okay, so this would be the ceiling tile for the lecturer, okay? And then the students would be covered by these beams. And again, we can see the range. Now you can change the angle of the beams, which means how far they cover. I'll go up to the extra large. So now, In the same room, or now we can cover a much larger room, 5.5 meters by 7.25 meters here. And this is with a 3-meter ceiling. We recommend the microphone be probably between maybe 2.5 and maybe 4 meters, something like that, between 9 and 12 feet for the best audio.